Hello, everyone, and welcome to Coffee with Caleffi. So we're just going to switch over to the presentation here, but wanted to thank you for joining us today. This presentation is going to be more of a high-level policy type discussion for an issue that we know is really important to this industry. It's something that's going to affect us in the short term and in the long term, and it's something that we want to present some of the policy level conversations that are happening right now to empower the audience to be able to be part of these conversations and help direct wherever decarbonization and electrification goes in the years to come. It's something that we've been talking about from the technical aspect for many years. We've got lots of resources that I'll talk about a little bit later in the presentation. But today we wanted to take that kind of 30,000-foot view of the topic with a guest speaker. So we'll go through a couple of slides here, and then I'll turn it over to our guest. Okay, looks like we've got the PowerPoint up. So if you have any issues with the audio, there is the technical support number. Sometimes just logging out and logging back in is a good way to go, but that's the best way to connect. This goes directly to GoToWebinar support. And then on the next slide, you can get a certificate of attendance. So this is going to be emailed to all attendees. It's important to know what your state and province is to include that, but you'll get a signature template certificate that you can use for whatever your authority having jurisdiction is there that accepts those. So at AHR this year, so it's almost coming up on a year at this point, we won the Innovation Award for a thermostatic mixing valve that we call the Angle Mix. This is actually something that will apply to the conversation that we have a little bit later. This would be a great mixing valve to use for a water heater and pipes together really well, so very contractor friendly, and is a technical topic that we can follow up with great detail after we discover some of the policy things that we're talking about today. The most recent issue of Hydronics right here, this is about heat exchangers. So this is something that is plumbing, this is heating, this is cooling, this is all over the industry. This is a great issue, something that comes up all the time, how to size, how to apply heat exchangers. This is available now and is also an online version, so you can do a simple PDF, or on the next slide, we've got an address for an interactive version. So this is something that we really love and we've worked hard on at Caleffi, hydronics.caleffi.com. And you can see the same information, but with a lot of supplemental materials too. So there may be related videos and things that will be useful as you go through the topic instead of just a static PDF. So check that out. Next month, we are going to be going into more detail about selecting the best water heater. So this will be a more technical version of the water heater topic that we're talking about this month. If you want to come back next month, December 16th, we'll go into the actual applications, how to figure it out, how to size it, and that type of thing with Bob Hot Rod Rohr as the presenter. Okay, if you are looking for technical details, these are the three hydronics that I would recommend. This is kind of the choice for the topic of the day. So hydronics 25, lowering water temperature in existing hydronic systems, air to water heat pumps, and contemporary hydronic cooling for commercial buildings. These are going to be the piping diagrams, the real kind of engineering red meat that you'd be looking for are in these documents here. So check those out if you want to see how to pipe this type of system together that we'll talk about in the rest of the presentation. And I think without further ado, we'll turn it over to Amruta Khanolkar. So she is our guest speaker today from the New Buildings Institute. She's a mechanical engineer. She knows all about energy efficiency, decarbonization. She has a master's in science from Arizona State. She is a policy expert and is going to guide us through the next few slides. We've got some interactions with polls and chat questions, so I'll keep an eye on the questions and turn it over to you. Thank you.
All right. Thank you, Max, for the warm welcome. Hello, all. Amruta Khanolkar, Senior Project Manager at New Buildings Institute. And I'm really excited to be talking to you all today and discussing this important topic. So I will be giving you an overview of how hydronic systems can play a key role in the fight against climate crisis decarbonizing the built environment. So before I dive deeper into the topic, just a little bit about New Buildings Institute. We are a non-profit organization and headquartered in Portland, Oregon, in the United States. So we have 3 key program areas where we work in: codes and policy, building, like program innovation, and market leadership and development, market transformation efforts. And through these key topic areas, research, policy, innovative programs, we push for better buildings which can achieve net zero energy, zero carbon, zero emissions. These are the 5 foundations that the entire work at New Buildings Institute is around. I'm sure you all are aware of energy efficiency, renewable energy. The third one is the grid integrated building. So not just an efficient and use of renewable energy, but also making sure that the buildings are grid interactive. Building electrification and decarbonization is a big piece, and life cycle impacts. Finally, to everything combining into a zero carbon building policy. Okay, so with that, with New Buildings Institute introduction, now I'm going to move on to today's topic. So I will start with giving a bit of a background on building sector and why there is need to decarbonize. Then dive deeper into like one system type each for space heating, cooling, and domestic hot water like heating. Go over some case studies, and finally wrap it up with some building decarbonization market transformation efforts that are happening currently. And I want to mention that let's keep this interactive. So if you come across any questions, I can take a pause and we can take a couple of questions in between. So let's keep this interactive. All right, so with that, I guess building decarbonization or decarbonization in general is making a press nowadays. I'm sure you must have seen all these news popping up, and just in last 2 to 2.5 years, over 42 cities in California alone have adopted electrification mandates. And so that is like, in a way, they are banning gas from new construction. So that's a big deal, like just 42 cities in California, and that's happening nationwide. So it is like, it is happening, it's in real. So it looks like we have a poll here.
So I'll go ahead and launch that poll. You should see that coming up. So go ahead and click through that. And what we want to know is that, California, I think, makes the news for decarbonization, electrification policy. But wherever you are, we want to know if you see changes coming, and if so, what is the change or what isn't the change. That's the type of information that would be interesting to know, to see where these conversations are being had. One of the things, again, that I want to mention is that these are open forums at all these different levels, at the policy, state, and local level. So if you are very passionate about this topic and think that it should go a very specific way, or think that it's not going in the right direction, we want to see where you're having these conversations. So I'll leave this poll open for another 10 seconds or so, and then we'll close it and share the results. Okay, so if you are unable to see it, it looks like we've got a mix here. So we've got 34% say that state level, 41% say city county level, and then 25% currently there are no policy changes in place. So that's helpful. That gives us an idea where these conversations are being had.
Cool. It is good to know that there are efforts happening at the state and city level. Thank you, Max. Okay, so with that, what this slide shows is space and water heating alone accounts for 2/3 of energy use in a typical household in the United States. So these two end uses are cornerstone to building decarbonization. It is really critical to tackle these two end uses to decarbonize the building sector. And so what we I just gave like a little bit introduction about decarbonization and how, why it is needed in buildings. And then so now few slides for next few slides, I will cover a radiant heating cooling system, which is like the efficient space cooling, space heating system type, and how it can support decarbonization. So radiant systems are, they use radiant piping for, I'm sure you all are experts, so I won't go much into the detail, but they use radiant piping to cool or heat the building. And the fact that they decouple ventilation load from the space cooling load, there is like a tremendous energy saving in fans and pumps. You don't have to run, you can avoid terminal reheat, so absolutely can avoid on fan energy as well as pumping energy. You can you also see like the overall the cooling plant efficiency is higher in compared to all air systems. The another key role a radiant heating cooling system can play is they can act as thermal batteries, because water has that thermal mass. They can act as thermal batteries. So basically, when the sun is shining, the wind is blowing, there is plenty of renewable energy on the grid. The grid is cleaner, the water can be heated and stored. And when the grid is dirtier, all that energy can be used. So all these hydronic systems can absolutely help the grid getting greener with shifting the load to off-peak periods. So what you see on this slide is the Center for Built Environments lab results, which compares all air system to radiant cooling systems. So the first picture here is all air cooling, whereas the second one is the radiant cooling. And if you see that in the first picture, the diffuser is blue, only the diffuser is blue. So somebody who is sitting right under the diffuser is going to be cold, whereas the rest of the people might be uncomfortable. Whereas in the radiant cooling, the entire radiant panel is achieving the mean radiant temperature. So it's not just energy efficient, but we have also found out that it is also comfortable. Like from comfort perspective, it is better over all air systems. And just from energy perspective, like the radiant heating cooling systems are about 20 to 60% more energy efficient compared to all air systems, depending on the type and climate zone that you are comparing the buildings against. And that's what is shown in the graph on the right, the energy impact. And what we have seen is these systems, the radiant systems, are also very common in high performing buildings. So NBI's net energy buildings database shows that over 42% of the net zero energy buildings are using radiant heating cooling. So absolutely, these systems allow buildings to meet the net zero energy targets. This slide shows that, again, going back to my comfort point, that maybe I will use a pointer really quickly. So from comfort perspective, the graph on the right hand side below shows that the radiant systems have a better satisfaction level compared to all air systems. People are responding to radiant systems more than all air systems. Again, it's a different way of like a radiant. You're using a radiant technology over a convection conduction. And with that, looks like we have another poll coming up.
Okay, I'll launch that one.
Do you want me to read it, Max?
So yeah, 5 years from now, what amount of projects that you design or install will incorporate radiant heating and or cooling, and then select increase, about the same, or decrease. Those last two slides are great. I'm a big radiant heat fan. I think that 42% of zero energy buildings using radiant is kind of the best testament to that. That if you're very serious about reducing the amount of energy that's used in a building, radiant heating and radiant cooling are just the proper technology to get to those really low energy use numbers, and something that don't sacrifice the occupant comfort. So we're not talking about turning the heat off in a building and everybody's going to be cold. We're talking about, in the survey that you showed, better occupant comfort and better energy efficiency. And one of the things that's in addition is it pairs well with a lot of different heat sources. So it may be something that is a gas-powered boiler now, but could be friendly to an electrification switch to a heat pump in the future, or at a minimum would just be a lot less energy used. So let's close the poll and I'll share those. So 54% of the crowd said an increased number of projects, which is encouraging to me. I was happy to see that number. 41% about the same, and then only 5% say a decrease. So that's good to know. Pairs well with a lot of different systems and is kind of future-proof, as John Siegenthaler says. So great to see that. I'll hide those results and I'll let you keep rolling with the slides.
Cool. Yeah, and to Max's point, like this is the distribution strategy, but like even though buildings have gas boilers, like in near future, those can, with this all decarbonization effort, those can be switched to water source heat pump or air source, like a ground source heat pump. Those can be tackled later on, but yes, like combining radiant heating cooling systems with electric source of heating can absolutely help with decarbonization. So what I covered the space heating cooling system type. Now next few slides I will cover the domestic hot water heating systems, not just for the residential sector but also for multifamily and commercial sector. And I'm sure you all know how heat pumps work, so won't go into the details, but basically they heat pump water heaters do not generate heat, they transfer heat from one location to another. So they just work like a typical, like a refrigerator. This slide shows the grid connectivity controls and how does that impact the operating costs of water heater operation. So basically I have all the different water heating technologies compared to one another. So the first one is heat pump water heater, the electric resistance tank water heater, a standard tank water heater, and a condensing tankless water heater. So those are the four technology compared. And the green bars are the comparison of emissions, whereas the lines are operating costs. So if we just look at emissions, heat pump water heater so can save or rather let's say the rest of the technologies are like more than 3 to 4 times they emit more carbon emissions compared to heat pump water heaters. From energy perspective, like heat pump water heaters are 2 to 4 times more energy efficient, reduce on emissions. And from operating cost perspective, if you are using all the heat pump water heater capabilities, which is grid connectivity, or the controls that come with the latest heat pump water heater models, then the takeaway from this slide is with advanced grid connectivity and optimized controls, heat pump water heaters can almost cost similar to tankless water heaters. So that's the blue line, that's the yellow line that you see here comparing the operating cost. So the technology does have a lot of potential, not just to green the grid, but also give the similar cost experience to the customer. I wanted to emphasize on the fact that the technology can support greening of the utility grid. As I mentioned, that the heat pump water heaters have, like, they can act as thermal batteries, heat the water when the renewables are plenty on the grid, store it for later time, and use it when the grid is dirty. So shifting the load to off-peak periods. And so electric resistance water heaters, of course, they use more energy. They have like 4,500 to 5,000 wattage, and they can shift 4.5 kilowatt of load to off-peak periods. Whereas heat pump water heaters, sorry, the electric resistance is about 15,000 use 15,000 watts, whereas the heat pump water heaters use 4,500 to 5,000 watts. You can see that the watts usage is absolutely 1/3, and hence the load shifting is also, like, heat pump water heaters can shift 0.5 kilowatt of load to off-peak period. So they do have tremendous opportunity, both in electric resistance as well as heat pump water heaters, to shift the load to off-peak periods as long as they are grid connected. So having a grid connected grid connectivity capability on the heat pump water heaters is key.
I think that this is probably my one of my favorite slides of the presentation, because I think that if someone were to say the grid cannot support electrification, if we snapped our fingers and everything was electrified tomorrow, and there was no natural gas, there was no propane, it wouldn't be able to do it exactly like we're doing it now. So a big part of this is to shift away from when people are waking up and getting back from school or work or whatever, and not use the heat pumps and use electricity. Then with this grid connectivity, we can shift that load. So we change the look of the green line there. So we're not trying to do electric resistance water heating at 8 in the morning. That will be something that's going to be significant to reduce the tax on the grid, because currently if you just had that electric resistance on all day at the same set point, it would be hard to keep up with that, much harder for the grid going forward as more people switch to electric. So really important, I think, that the heat pump manufacturers are moving in that direction. I think you've got some other slides that get into detail there.
Mm-hmm. Yep. Thanks, Max, for elaborating on that point. So this slide shows that what manufacturers, like the manufacturers are, and the technologies that are coming to market or already in the market. So these are all the top heat pump water heater, the residential, like the Unitary heat pump water heater manufacturers. And the second column shows that the 240 volt heat pump water heaters are decades old, more than 4 decades old, and are in the market for quite long time. But there are these new 120 volt heat pump water heaters coming to market, an emerging heat pump water heater technology, and I will elaborate on those in few slides. But just wanted to mention, these are just plug and play water heaters, so they do not require any panel upgrades. Let me elaborate on that on next few slides. What you see here is almost all of the manufacturers have a CTA 2045 standard port for grid connectivity, so they are all moving into the same direction. And refrigerant wise, right now some of them are looking at medium and low refrigerant options. So for next couple of slides, I'm going to cover the opportunity, like the national opportunity, particularly with heat pump water heaters have with decarbonize, to tackle decarbonization. So there are about 118 million residential water heater, existing residential water heaters currently, about 4.7 million commercial commercial water heaters. About 40 million of those 180 million water heaters are 10 years and older, so they are about close to their end of life. And just for statistics, more than 7 million water heaters get replaced every year. So heat pump water heater, this technology, and particularly the new technology, the 120 volt, which is just plug and play, no panel upgrades required, has tremendous opportunity to tackle this market. And this slide shows the water heating stock, the fuel stock. So the last row is the national stock, and the second last row is the California stock. I wanted to emphasize on that. So like nationally over 50, like about 50%, but in California alone, so maybe I should explain the index first. Everything in light blue is electric water heating, and everything other than the electric are all fossil fuel based water heating fuel types. So, and if you now look at those last two slides, 50% nationally, and about over 90% of water heating stock in California is directly pumping fossil fuel for heating their water. So for these customers, if they want to decarbonize right now, okay, looks like we have a chat question. So what is the biggest obstacle? Maybe I'll take a pause and ask everybody, what is the biggest obstacle that you see in the shift from residential gas water heaters to heat pump water heaters? Type your comment into the chat.
And we're waiting for those answers to come in. I'll go through a couple that we had a little bit earlier. So one of them was, do you see issues with condensation with radiant cooling? So I would point you to Hydronic's 28 as a perfect place to look for that. Commercial new construction with proper controls, condensation is not something that is going to surprise you, especially with these systems. We don't want to send water from a chiller out to the building at 33 degrees Fahrenheit. We're talking about pretty cool temperatures. So if it's not condensing leaving the mechanical room, it won't condense any further out into the building. Is completely achievable, and Hydronic's 28 is a good place to look for that. Another one is for one of the slides we talked about water heater emissions. Does the carbon emission cost assume, I mean, essentially, this is grid dependent. So if you're in a place where you're burning a lot of coal, it may still be more emissions that have shifted to a coal power plant, but in the graph that was shown earlier, all of this depends on incorporating more renewables. So we're talking about on-site use. Maybe we'll be able to offset some of this with solar on top of the building, but big picture, the grid has to get more green as well. So the graph shows using wind at night, using solar during the day, and then cutting the use when you would have to use some sort of carbon-based peaker plant currently, if it's natural gas or diesel, to be able to keep up with that surge, that peak. So I'm interpreting the question as versus wire-to-wire electric resistance. It's going to be better with the COP of the heat pump to be able to decarbonize, to use less energy, and then it has to be coupled with a greener grid. And one of the things that we don't talk about here, because it's not really in our wheelhouse, is better buildings, better insulated buildings. We mentioned in the last electrification webinar that if you take all of this technology and put it into an old leaky house, you're not going to be able to solve all the world's problems that way. So there's a lot of building envelope stuff that has to happen to be able to enable this to be the best version of itself. So those were a couple things. And then let's see. We got a bunch of questions that were just entered for that last one. We'll see if I can pick out a couple. In the analysis that you show on this page, I think that shows kind of the difference between different parts of the country. We had a question about northern versus southern climates. How would you say that the heat pump research, are you looking at kind of all of North America when you look at those statistics for how heat pumps perform in different climates?
Yeah. So cold climate heat pumps, like just heat pumps, not just water heaters, but cold climate heat pumps is a big research that is, or not just research, but a technology that is available for space heating purposes, which just tackles like better COP, uses CO2 as a refrigerant, and are better for colder climates, even like Canadian climates. So yes, that is a thing, and the technology is available. Regarding heat pump water heaters, there are also cold climate heat pump water heaters, specifically with CO2 refrigerant, which does help with higher COPs and colder climates. So yes, there are colder climate heat pump water heaters available too. Regarding your comment about, since we are on the COP topic, just for comparison, like an electric resistance of with a COP of close to 1, a gas tank water heater with thermal efficiency of about 0.6, like 60% of thermal efficiency, and a tankless like 90% of thermal efficiency. Compare all this to a heat pump water heater with a UEF of about close to like 3 to 4, it's almost like 3 to 4 times more efficient just in the performance. And yes, the weatherization does play a key role to reduce the overall impact, to reduce the peak of the building, in addition to all these, a heat pump water heater or a space heat pump or a radiant heating cooling system.
Great. One of the other questions that we got is, there is a question of load shifting. So if we put a tankless, or if we put a heat pump water heater down in the basement, are we now just changing what we're paying through the heating and cooling load of that space? And that is a concern. And there are some places that, depending on how these systems are installed, it's not necessarily going to be a great fit to put a heat pump water heater right behind the living room in the center of the house. There are different parts of the structure that are going to lead to less load shifting, or if it can be, basically ducted outside. The commercial units are a completely different story in that sense too. So yeah, that is something that needs to be addressed. Not every single mechanical room can just do a cut and paste with a heat pump water heater and not expect their heating and cooling loads to change because of that, because you're shifting where the energy is coming from. A bunch of, we won't be able to answer all these questions. We just got a flood. A bunch of these are cost about heat pump water heaters. I think today is probably a different conversation than even a year from now, based on the slides that were shown before, as far as all the different manufacturers that are getting into the game that do traditional water heaters now, that are coming with more heat pump water heater options. In other parts of the world, they have started down this road much earlier than we have in Japan and in Europe. So I would guess that the prices are going to come down for these heat pumps, but I guess we've got the expert here. What do you think about the installed cost of heat pump water heaters going forward?
Yeah, and actually the market transformation efforts that I will be covering, I will go like in depth about, supply chain and how does that impact like the economy of scale, and how does that impact taking the first cost and installation cost down, not just economy of scale, but educating the supply chain, workforce development, and how does that impact taking the first cost down, and what efforts that are currently happening to make that happen, like, to tackle that barrier, the current barrier. So yes, such market transformation efforts and educating awareness of not just the customers but supply chain is key to adoption of these technologies.
Great, perfect. Well, I'll save some of the questions. I'll let you get back to your slides, then we'll come back to a few of them at the end.
Sounds good. So I will just going back to there is a big percentage of customers who are on fossil fuel water heaters, and for those customers, if they want to decarbonize, the only option they have currently is going for expensive and extensive panel upgrades. So if you are replacing a gas water heater with an electric water heater, typically you have to spend $1,000 to $3,000 for panel upgrades because you don't have a 240 volt outlet available right next to the water heater. But with this new technology that I mentioned, the 120 volt, you no longer have to do that. These are going to be just plug and play water heaters, and you can use an existing outlet, 120 volt outlet, to start using those water heaters. So they are going to be a game-changing technology once validated. And I want to mention that currently we are, like NBI is working on validating this technology, this new technology, 120 volt heat pump water heaters in California and Pacific Northwest. Okay, so I've covered the residential aspect, the unitary heat pump water heaters. Now, for next few slides, I will cover the multifamily or the commercial central heat pump water heater systems, and emerging technologies on that side. So what you see here in the picture is a custom mechanical room where you have a storage tank, a compressor, all the piping, everything is custom designed. Like the compressor, the storage tank, the stratification, everything custom design. But what through the Advanced Water Heating Initiative, which I will introduce shortly, what we are working on is a packetized system design, which is going to be a packaged plug and play system, so that you can see a better adoption of these system types. The main barrier with central systems currently is its custom design. I guess once you have packetized plug and play systems, that the majority of the barrier will be gone. Ecotope, the partner on Advanced Water Heating Initiative, is in fact working with the manufacturers on these future designs, like packetized skid mounted designs. And this is a picture from a demonstration project that is happening in Seattle Housing Authority's Bayview project. Again, what you see is this plug and play central system going into the housing. It's, I guess, 140 unit medium-sized multifamily application. So till now, there was just one COP for the actual heat pump water heater piece in the central heat pump water heaters. But with this new approach, what we're proposing is the heat pump water heaters, the storage tanks, the piping, the controls, maintenance system. There will be an entire domestic hot water system COP. And the NEA, the Northwest Energy Efficiency Alliance, in fact, now has a specification developed around a system COP, and is part of their specification, the Advanced Water Heating Specification version 8.0. And we have a poll coming up. How comfortable would you be in shifting to heat pump water heaters for residential commercial projects you design or install starting today? We have some options. All of my projects could utilize heat pump water heaters. Most of my projects could utilize. Few of my projects, and I would only use gas-based systems to heat water today. But I'm open to heat pump product advancements. I do not plan on shifting away from gas-based systems. Yeah, I'll be curious to know what everybody thinks.
Okay, those are starting to come in now, so I'll display those results in a second. We'll give it another 15, 20 seconds there. But I love the slides about the skid mounted systems too. I think that was important in the past, but especially in the COVID era of construction, to just have a box that you can drop into the mechanical room or crane up onto the roof that's going to have the best technology ready to plug in is just such a smart way to do that. And regardless of what the mechanical equipment is, I really enjoy seeing manufacturers and mechanical contractors doing that, because it's just going to be able to get the another thing that can help us avoid some of the skilled labor gap is if we can do a lot of this in our shops and then just send it on a truck and plug it in. So I will go ahead and close the poll and I'll read through those results. Okay. So how comfortable would you be in shifting to heat pump water heaters? 8% said anything, everything starting today. 32% said they could use heat pump water heaters for most. 47% said few. And then 10% said only use gas-based, but are open to different options for now. and then 4% say gas-based systems are what they're going to stick with. So that's pretty interesting. I guess that's a pretty good bell curve there, but it looks like you are comfortable enough with the technology that exists now, and if more manufacturers on the heat pump water heater side get in the game with these different versions that were shown, that might change that a year from now. So interesting.
Mm-hmm. Yeah, that was a good segue for us to like move from a technology discussion, like a systems discussion, to market initiatives and efforts. Now in few slides, I'll cover that. So these are some of the market transformation or decarbonization efforts that are happening currently in the United States. The first two are, I will be going deeper into those. And then there is also a Building Decarbonization Coalition in California and Midwest. NBI has a Grid Optimal initiative going on. The Green Lining Institute, in fact, has a decarbonization effort which couples equity aspect to it. So lot of momentum currently. The first initiative I will talk about is the BETTER, which is Building Electrification Technologies Roadmap. It's NBI with its Building Decarbonization Coalition is working on this effort. And the goal of this effort is to identify electric technologies that are ready to replace gas technologies and to accelerate the adoption of such technologies. And it is to help support utility programs, like program administrators, governments, cities, to understand what technologies are available if they are adopting electrification mandates. Again, it tells us, like, what technologies are available, what the current barriers are, how can you adopt them more. And the way it is doing, the 5 strategies that we are proposing is 1, build demand; 2, support supply chain, like awareness, training of supply chain, workforce development, partner with production. Manufacturers are key, so you need to work with them to come, like to come up with all these new products that I mentioned, to show them demand, so that that continues. Close the cost gap. Costing is a big deal, and yes, we need economy of scale to achieve that. And align programs and policy, like in addition to the technology advancement and market creation, you also need policies and incentive program, utility incentive programs to support electrification effort. The second initiative that I will cover today is the Advanced Water Heating Initiative. And the slides that I covered, the residential unitary 120 volt heat pump water heaters, the central heat pump water heaters, is in fact work of this initiative and the working groups. So the Advanced Water Heating Initiative is a market transformation initiative of like over 150 organizations coming together. And we have representation from industry, like manufacturers, utilities, cities, program administrators, and it's led by New Buildings Institute in partnership with our, like, thanks to NEA, Bonneville Power Administration, US Department of Energy, in fact, just announced support to the initiative March of this year. So it is DOE supported effort. California Energy Commission as well as RMI is also partnering on this effort. You can read more about the effort on advancedwaterheatinginitiative.org. Our vision is to make heat pump water heaters mainstream by 2030. The goals, I guess, I know these are ambitious goals, but for residential market, like 100% market share by 2030 becomes heat pump water heater, and for commercial 90% by new construction market segment heat pump water heater by 2026. Ambitious goals, but we are working towards it. So we have 3 working groups. The residential working group, which is again the 240 volt product is available, we need to create demand, and the 120 volt is the that once which one I talked about, that one is the one when forgot to mention, but has an integrated mixing valve because it does not have a supplemental heat element to it. I won't go into those details, but basically this working group is not just working on technology advancement, but also seeing how market can be developed and how policies and programs can support. Same thing with commercial and multifamily. And then there is policy working group looking at national and regional policies, appliance standards that can help support the goals. So it looks like there's a chat question. If you have strong opinions about decarbonization policy, where do you plan on engaging with the topic?
This is something that we wanted to ask. The last few slides have shown at a policy level and at a manufacturing level where you can get involved. But if you are an engineering firm with 10 people in Topeka, how do you get involved? Where do you want to have your voice heard? And I think that if we could get some answers from the group, that would be great. While we're waiting for those to come in, let me look at a couple other things here. So as far as, let's say that you're going to electrify and try and decarbonize Fairbanks, Alaska. So that is a little bit tougher topic right now because it is extremely cold. But as the technology gets better with these systems, I think it's going to open up more of these markets. Another question was high electricity rates in the Midwest still make gas a good option because of the cost there. Again, that may start to shift if the price of gas and propane starts to go up and the economies of scale of these electric heat pump water heaters and radiant systems start to make that payback come back down. I think that we are at a tipping point in California already. That's probably in the past because of the prices for energy out there. For somewhere like Nebraska, that may be 5 or 10 years away. But I think that because there are so many people and so many buildings that are looking in the direction of heat pump water heaters as an option, that it's going to become less expensive and it's going to bring that parity a little bit quicker than we probably see today.
Mm-hmm. Yeah, I can like quickly add to that. So yes, cost parity is key to market transformation, and like even though the gas prices are lower, in fact, in just few rate structures that are coming out, gas prices are already going up, and it is important to help the vulnerable or the communities to get on electrification first, because the people who leave behind typically get the impacts of there are going to be less gas lines, more maintenance requirements. So in fact that in future you will see the gas prices are not just the gas prices are going up, but also the support pricing, like required for gas rate structure, is also going to go up. So we have to support the vulnerable communities, and like equity is going to be key for these market transformation initiatives. So
one of the things
yes,
too,
correct.
that if we looked at an example with cars, that maybe 5 years ago, 10 years ago, you would have been looking at a very long return on investment to go all electric with cars. Looking at the gas prices today, it is a little bit different story. So if you had purchased an electric car 5 years ago, that payback is different. And I think that maybe the heating and cooling and DHW market may be a similar story a few years from now. One of the comments that I got, our firm, our architecture and engineering firm, is actively looking for ways to reduce carbon footprint for our projects. We use life cycle cost analysis to justify to our clients the lower carbon technologies to make sense to us. So again, this is a bigger conversation. This is a life of the building conversation, not a the cheapest replacement today may still be a gas water heater, but is that going to be the best long-term solution? And I think that the answer is changing.
Mm-hmm. And to your point, like Max, like even though gas might be just from a first cost perspective might be cheaper, but with where this administration is going, like the utility incentives are all dying down for gas equipments, and in fact the incentives that utilities are providing to electric equipments are going up. So with those incentives, it is becoming pretty comparable, like, a heat pump water heater compared to a tankless or a tank water heater. You have $1,000 incentives coming from a utility, in fact, even $2,000. And that is getting like the economics is looking much better with, as I said, programs and policy support on for these technologies before they achieve economy of scale. So yes, as I'm I think I should mention utility incentives and policy does play a key role, and that's the whole effort about the Advanced Water Heating Initiative. And if you want to know more, please send an email to info@advancedwaterheatinginitiative.org. And I know we have 10 minutes left. I want to keep some time for question and answer and have more discussion. So the takeaways from my presentation today is building decarbonization is essential, is critical to take care of the climate emergency. Hydronic systems can play a key role in building decarbonization, and they are they can act as thermal batteries, heat the water when the grid is cleaner, sun is shining, wind is blowing, and use the water when the grid is dirtier. So they play an important role for load shifting and for making the grid greener. So with that, I would like to thank you all and open this up for more discussion and questions.
So we have a bunch of questions. Let's see if I can go through a few of these. So one of the things that that comes up when I hear this conversation is that in California they have brownouts all the time. How does adding more electrical equipment to the grid help that? And I think that we've talked about this in a few different ways, but we can kind of go back to a couple of these points. So if we were just to plug in electric resistance water heaters and electric boilers to the grid in California or in most states, it wouldn't work very well right now. So that load shifting is a big part of it, to lean on the renewables more when the sun is out, when the wind is blowing. And then one of the things that we talk about all the time in the hydronics world is that water is such an excellent vessel for heat. So the reason that we want to be part of this conversation is that we already know how to do all this stuff with radiant heating, with radiant cooling, with effective storage of DHW, with a mixing valve that we can store it a little bit warmer and then mix it down to the temperature that we're looking for at the point of distribution. We have a lot of the things that are going to take these spikes out of the grid. So it's not just electrification means brownouts, which nobody wants. So that's one of the things that I mentioned in the Hydronics 25, lowering water temperature, 27 air to water heat pumps, and 28 cooling. We have these technical answers already. That's one of the reasons that we reached out to the New Buildings Institute, is we want to see what's happening at the policy level, but we also want to make sure that everybody on this call remembers how important you will be to the transformation of this market, and how we can do it effectively and how we can do it using common sense. But it won't necessarily go the way that you want if you don't have your voice heard. So reaching out to local politicians, reaching out to the manufacturers who provide the products that you use, to make sure that this isn't something that passes you by in a way that you don't think is technically feasible. But it is possible. So what else would you add there in kind of the broad brownout topic sense?
Yeah. So about the question, if we were to just switch to electric resistance boiler or an electric resistance water heater, I think we want to save our grid. So basically, as I mentioned, an electric resistance is about 15,000 watts, and heat pump water heater is 1/3 of that, about 5,000 watts. And the 120 volt is even lower, like about 900 watts. So we want to make sure that amp diet is going to be a key to support our grid when we are electrifying. And as I mentioned, there are different techniques that the manufacturers are coming forward with, like, with this electrification. So for example, for the 120 volt, what they are doing is removing the electric resistance element, and that's why the wattage is so lower, and adding like bumping up the water temperature. Instead of 120 volt, they will heat it to 140 volt, and then adding an integrated mixing valve, which I see a great tie-in with what Caleffi is doing. So that allows this technology to be pulling in lower wattage from the grid, but also give the same comfort to the customers, to help electrification and also support customers with electrification.
And that's kind of related to another comment that we got, that most commercial heat pump water heater systems require so much storage that an existing building may not be able to handle the structural loads on the roof, for an example. And that's a good point too, that we would need to have less storage in some cases and store it a little bit warmer, and then mix it back down. So the more technology that we can get to have a higher output temperature with those heat pumps, the better we can get away from so much storage. So it may make more sense for some buildings than others. In new construction, it can be designed around. In a retrofit, that's going to be the technology that we would need to be able to add some heat pump water heaters to the top of a building, as an example.
And about the central heat pump water heaters, I think I missed mentioning that the pilot project that I showed you, the Seattle Housing Authority, they reduce its energy input by 1/3, switching from a gas water heater to a central heat pump water heater system. So the peak load reduces, like if you design the system correctly.
And that may be a good point too, that if you're going to save that much money and that much energy, you may be able to justify an upgrade to the structure of the building, to say, okay, we're going to need to reinforce the structure a little bit to be able to put in this heat pump water system, but it's going to be worth the X number of $1,000 to make the structure ready for that additional weight of some storage. So we've got another question about refrigerants. So what's the importance of much lower global warming potential refrigerants in the face of increasing heat pump uptake? So CO2 or ammonia, or what are some of the kind of emerging refrigerants that you see these systems using?
Yeah. So CARB, the California Air Resource Board, has like these this low, medium, and high bins for these refrigerants. And I mean, I was going to go to the slide, but that's fine. And based on the categories they have created, manufacturers are in fact moving from a high global warming potential to a medium and low global warming potential. And in fact, I hear that CARB's 2023 and 2025 regulation is going to push for all the high global warming potential refrigerants to be out of the market. So it's going to only focus on like low global warming potential, or medium, which is like CO2, ammonia based, or even the R134A, which are all like low to medium GWP refrigerants. And again, I want to mention that the Advanced Water Heating Initiative's position is to push for heat pump water heaters and let CARB handle the refrigerant piece, because these are all closed systems. So not that the refrigerants are directly impacting. Only if there is a leakage, yes, there is they are going to impact. But just looking at the energy and emissions savings, switching to a heat pump water heater, there is so much potential, 70 to 80% potential energy and as well as emissions. So we don't want to wait for that transition to happen. The market should continue with the transformation, and when these new products are there in the market, we will incorporate them.
Great.
Does that answer the question?
I think so, yeah. So why don't we roll through the last few slides here to wrap it up, and then I'll take one more look at the questions, just since we're about to the top of the hour here.
Yeah, I guess this is the last slide.
Okay, so coming up next month, we have a topic for Coffee with Caleffi. Let me just pull up the date again here. So it's going to be on Thursday, December 16th. That's going to be how to select the best water heater. So kind of a technical continuation of this presentation. Then beyond that, we wanted to mention that the Ask Caleffi podcast is available. Look for that for ways to go over some phone line calls that we get from the field, how to troubleshoot things, what to look for in order to make your job easier if you're out turning wrenches. That's a great thing to listen to in the truck on the way to work. 5 Things You Need to Know video series that Cody Mack does at Caleffi. Great for a distributor audience, short videos, 5 to 7 minutes that cover topics that we have probably covered in Coffee with Caleffi at some point, but just in that smaller bite that could be a great fit for standing at the wholesale counter or something like that. And then follow us on social media, LinkedIn, YouTube. You can find all of the archived Coffee with Caleffis, including this one in a few days. Facebook, Twitter, and Instagram. You can find out what we're up to there and see some of the case studies that we've come across, because the success stories out in the field are what we love to see there. So that kind of takes us to the end of the Caleffi slides there for things that are coming up next. Let me pull up the questions box one more time and see if we got any additional ones at the end there. If you are looking for slides of the presentation, click that at the end of when we end the webinar. There'll be a survey, and click that you'd like to see a PDF of the slides. And then I think the other ones, I don't see any new ones. There are a lot of very specific questions that we might have to answer offline in a little bit more detail. We've got, I'll do one more. What is the role of solar thermal for DHW? That's something that at Caleffi we were very big in a few years ago. We saw a pretty big shift when the rebates changed to solar PV because the price came down so much. What are you seeing at NBI with solar thermal? Is that something that has a future to rebound a little bit?
Mm-hmm. Yeah, solar thermal is a big piece. And I do want to mention that NRIL, the national lab, has a report which actually looks at so solar thermal, it's pretty climate dependent. So in some areas it might be great, but not in all the areas. And the feedback we have received is with the maintenance and the workforce development, like the supply chain issues. We have seen some supply chain issues, the maintenance, the requirements, and that's why it has not picked up as much. But in some areas, if you combine the solar thermal piece with the heat pump water heater piece, they can be great. But at the same time, yes, there are some barriers for solar thermal, mainly from maintenance perspective. That's where those systems are currently, but hopefully they do hopefully they do spring up.
And one of the things I'll mention there too is that if you have a very consistent, very large domestic hot water load, all of that's going to make more sense. If you're trying to heat a pool for a rec center, or it's a laundromat or something like that, it starts to pencil out a little bit better to incorporate solar thermal too, where for better or for worse, the solar PV people have been able to drive down their prices so low that it makes a lot of sense to use PV in residential, commercial, industrial scale projects kind of across the board. So
yeah, absolutely. And I guess maybe installer trainings and awareness could also help that industry, just awareness building, maintenance trainings could help that industry.
Sure. Well, we've got, looking further back in our archives, Hydronic 3 and Hydronic 6, if memory serves me, are on solar thermal. So we're happy to go into more detail there, but that will be probably the topic for another webinar. So I wanted to thank you, Amruta, for walking us through those slides. Really interesting to see what's happening at a policy level. Whatever your take on this issue is, make sure you get involved so we get realistic paths forward for whatever your zone or market or region may be, because this is something that isn't going away. It's in the public sphere now, something that a lot of policy changes are happening. So make sure that you get involved to be able to help direct that in the proper direction for your business. So thank you again. We'll go ahead and close it up, and then we'll get back to some of those questions in the next couple days that require a little bit more specific answers.
Thank you all. It was great
Thank you.
talking to you.
Thanks.